Hello everyone, my name is Purkait, Assistant Professor of Swami Vivekananda Institute of Science and Technology. Today we are going to discuss about a topic which is Maxima and Minima. The topic name is Maxima and Minima. Maxima and Minima of single variable. Of single variable. We are taking the variable as x. Okay. Now there is a problem. Show that the maximum value of the function 1 by x to the power x is e to the power 1 by e. For proving that, first of all, what is the necessary condition of a function to be maxima or minima? The necessary condition is f dash x equal to 0. Fx is our function. Suppose fx is our function and the first order derivative of the function will be 0. If it is 0 and we get x equal to c, suppose, and then the second step is, this is the first step of calculating this maxima or minima. This is our first step. We have to check the derivative of first order and equate to 0 and then get the value of x. This is the first step. Then the second step is step 2. We again find out the second order derivative of our function f double dash x and at x equal to c. Suppose the value of x is c. At x equal to c, if we find f double dash c is less than 0, then x equal to c is a maximum point. And if the second order derivative at x equal to c is greater than 0, then x equal to c will be minimum point. And the function has maximum value at this x equal to c point and the function has minimum value at this point. Okay? And if the second order derivative is equal to 0, then we have to again derivative f triple dash x and so on. Now, using this formulas, now we solve this problem. The function, the maximum value of the function 1 by x to the power x is e to the power 1 by b. Fx is our function 1 by x to the power x. Now, what is our step 1? Our step 1 is we calculate the first derivative our fx. So, f dash x is equal to, before calculating f dash x, since it is a power type function, so we will take log function both sides and make this easy. Log fx is equal to x log 1 by x. Now, 1 by x can be written as x to the power minus 1 and log of x to the power minus 1 can be written as minus log x. So, log of fx will be minus x log x. Now, we start derivative. Now, derivative both sides with respect to x, we get the derivative of log is 1 by, if it is log x then 1 by x. So, it is log of fx, so the derivative will be 1 by fx. Again, derivative of fx with respect to x will be f dash x is equal to minus x into log x. Since there is two types of function in a multiplication form, so we apply the uv method of the derivative. U into derivative of v plus v into derivative of u. So, x into derivative of log x is 1 by x plus log x into derivative of x is 1. So that is minus x cancel 1 plus log x. From here our first order derivative f dash x is equal to minus of fx into 1 plus log x. Now we put the value of fx, since we know that the fx is 1 by x to the power x. Here we put the value of fx. So our f dash x is 1 by x to the power x into 1 plus log x. So our step 1 complete, that is find out the derivative of our function. x equal to 0 and find the value of x. F dash x equal to 0, that means 1 by x to the power x into 1 plus log x is equal to 0. Okay, so from here 1 by x to the power x is equal to 0 or 1 plus log x is equal to 0. Now this type of function does not give any solution. So we have to does not give any solution. So we have to take this for finding x. Log x is minus 1 and we know log e is 1. Log e is 1, so in place of 1 we can write e, that is minus log e. So log x is equal to minus log e can be written as log e to the power minus 1. Now log both sides we can cancel. So x equal to e to the power minus 1, that is 1 by e. So that is our c. That is our c, x equal to 1 by e. Our step 1 is complete. Now we are going to step 2. Step 2, that means we find the derivative, further derivative, that is f double dash x. F double dash x from f dash x. Our f dash x was minus 1 by x to the power x into 1 plus log x. Our f dash x was minus 1 by x to the power x into 1 plus log x. Now we find f double dash x. F double dash x equal to, we are taking minus and this is u, suppose this is u and this is v, this is total v, this is u and v. Again derivative of uv, u into derivative of v plus v into derivative of u. U means 1 by x to the power x into derivative of v means 1, derivative since it is constant 0, log x derivative 1 by x plus v into v means 1 plus log x into derivative of u, and you see that this u is 1 by x to the power x, which is our fx. So derivative of u means derivative of 1 by x to the power x, that means f dash x. Derivative of u means u dash means f dash x, and we already find f dash x here. We already find our f dash x. So we can put this value of f dash x, that is derivative of u here, which is minus, so that will be plus into minus 1 by x to the power x into 1 plus log x. Okay, so f double dash x is minus, this is 1 by x to the power x into this is 1 by x to the power 1, so that will be by index 1 by x to the power x plus 1 minus 1 by x to the power x into 1 plus log x into 1 plus log x, so that will be 1 plus log x whole square. So finally that is our second order derivative. Now the formula is method is we put x equal to 1 by e in place of this x, and if it is less than 0 then the function has maximum value, and if it is greater than 0 then the function has minimum value. Now we are putting x equal to 1 by e equal to minus 1 by e. In place of x we just put 1 by e. So 1 by e will be e to the power 1 by e plus 1 minus, again this 1 by e, that is e to the power x means 1 by e into 1 plus log x. Log x means log 1 by e, so that will be minus log e, that is minus 1. So log 1 by e will be minus 1, so plus 1 minus 1, that portion will be 0, so that is will be into 0. So that portion is 0, so only this is minus 1 by e to the power plus 1. And since it is multiplied by a negative sign, so f double dash 1 by e will be less than 0, and we know that if it is less than 0 then the function fx has maximum value at the point x equal to 1 by e, and this point is our maximum point. Now we have to find out the maximum value which we have to prove that e to the power 1 by e. Suppose e to the power 1 by e, I think. What was the question? E to the power 1 by e. So lastly we put this value. Lastly we put the maximum point in our function fx, which is 1 by f of 1 by e, and function fx was x to the power function fx was 1 by x to the power x. So now in place of x we put 1 by e, so 1 by x will be e to the power 1 by e. So this completes the proof. So in this way we can solve the maximum value of a function by maxima and minima formula or method. Thank you.